Hi, this is our ICCV 2023 work, Pseudo Flow Consistency for Self-Supervised 6D Object Pose Estimation. Current 6D object pose estimation methods follow the data-driven paradigm to train the model using a large number of real images with accurate 6D object pose annotations. However, annotating 6D object pose is hard and prone to contain large labeling errors. To solve this problem, self-supervising is a promising direction which aims to train the model on unannotated real images. Existing self-supervising methods mainly utilize the teacher-student learning framework. The teacher network dynamically generates pseudo-labels to supervise the student network, and its weights are updated from the student at every training step. For this framework, the key is how to select high-quality pseudo-labels from the teacher network's predictions. For the standard classification task, we can take the predictions whose probability of any class is above a threshold as valid pseudo-labels. However, there is no such easy way to determine the quality of 6D object pose prediction. In this work, we formulate 6D object pose as pixel-wise flow representation. Thus, we can utilize the flow consistency across multiple views based on the underlying geometry constraint to select high-quality pseudo-labels. As a result, compared to existing methods which rely on additional information such as depth or masks, our method is the first self-supervised 6D object pose estimation method which can be trained with purely RGB images based on the flow representation of the 6D object pose. Our proposed framework is composed of two steps. Firstly, we train a pose estimation network on synthetic images by rendering the object's 3D mesh, and infer the initial poses of the unlabeled real images using the trained pose estimation model. Based on these inaccurate initial poses, we train our refinement module, more specifically, a flow network, on real images without annotations. We use flow consistency across multiple synthetic views to choose valid pseudo-flow labels. Specifically, given an unlabeled real image and its initial pose, we randomly sample poses around the initial pose and render them, resulting in multiple synthetic views. Then, the teacher network predicts the flow between each of them and the real one. As each 3D point corresponds to different 2D pixels in these synthetic views, the predicted corresponding 2D points from these 2D pixels should be consistent. We use the variance of these predicted corresponding 2D pixels to determine if the pixel-wise flow prediction is high quality. We further explore the consistency between multiple real inputs, based on the motivation that the 2D image reprojections of the same 3D object point on different frames of a video share similar textures. Again, given an unlabeled real image and its initial pose, we query another several images in the same video sequence. The predicted corresponding 2D pixels from the same 2D point in the synthetic image on these different real images should be photometric consistent. Here, we show the effectiveness of our proposed flow consistency. The performance of baseline without our proposed flow consistency is close to the accuracy of the initial pose, which suggests the refinement framework cannot work without explicit quality measurement of pseudo-labels. With our proposed flow consistency, the performance increases significantly. From the training perspective, the baseline struggles to converge. However, with our proposed flow consistency, the model can steadily converge. On the other hand, we show the normalized variance and flow error at increasing training steps. Starting from texture well areas, our approach progressively predicts more confident and accurate flow across the entire object, while the baseline struggles to converge. Also, the variance can effectively reflect the flow error. We present our quantitative comparison here. On YCB video, our self-supervised refinement boosts the initialization accuracy significantly and achieves similar performance as versions trained with fully annotated real images. On LINEMOD and occluded line mod, our method trained with purely RGB images can achieve similar even better performance compared to previous methods relying on depth or masks. Finally, we show the qualitative results. Our method significantly improves the baseline in various conditions, such as occluded, weak textured, and symmetry objects. Thanks for watching. Our source code is publicly available.